Welcome, ladies and gentlemen, to the 10th tutorial. In this tutorial we're gonna automatically join walls with each other. And what the purpose is of this script is, let me just show you. Select wall. If I draw a wall here, please computer, yes, nice. And I draw another wall here, like so. And if I say, alright, I want to have a window inside my wall, a window, like so. And this is our inner wall, this is our outer wall, this is brick, this is lime. And it won't make an opening in the outside wall if I drew my window in the inside wall. And if I delete it and I create a window in the outside wall, it won't make a hole in the inside wall. So normally in Revit, let me just click it in the inside wall like so. You can do this by clicking on the Modify tab and then selecting Join. And if you click on the two walls, you can say join them. And now you can see there's a hole inside our outer wall. But we can also do this with Dynamo. And Dynamo will do that for all walls in our model at the same time. And so we don't have to click join and click on all our walls inside the model. So let me delete this. Please, keyboard, nice. All right, this is our test project. And for the example, I'm gonna draw a wall with, yes, this. We zoom in from here. Oh, that's a little bit too close. From here, yes, it's better. So over here. All right. And if you go to a 3D model, you can see we don't see any of the walls and we don't see our door. So we're gonna make a script for that, and let's go to Dynamo. All right, welcome in Dynamo. For this script, we don't need any of the packages. We just need one custom node, and this custom node you can download from our website, and I'll put a link in the description. And this node is element.join. And this node is what we made at Your Ydea. And this node allows you to give in two elements, and the result is they're joining or they were already joined. So the example, the input should be something like a list with, for example, object 1 and object 2. So these are normally elements. The input should something be like this. And you can connect it and it will give a result. And if you want multiple items, so we have, for example, 4 walls, we need to create a list like this and like this. And this is wall 2 or wall 3 and wall 4. And we need to close it in the code block like so. This should be our end list. Our end list needs a structure of this format. Let me delete this. And then we can connect it to our element.join. But first, let's get started, and let's get started with collecting all the walls. So we need category, this one. Let me delete this node first, like so. And we need all elements of category, and let's connect it and search in the drop-down menu for walls. So walls, all right. It obtained all the walls from our model. And let's see, it has 16 walls. All right. These are all the walls in the model. And what we're going to do is we're going to do a bit of a class detection actually in Revit. So let me explain it, what we are gonna to build, how we're gonna achieve our goal. Let's go to level 1. All right. What we're gonna do is model line, yes. All right. This is our wall, for the example, the green line. And the other green line is our second wall. So it represents those two walls. And if I select those walls, normally, you can see here's my point. This is my end point. And this is in the middle of the wall. So it's in my case. So that's representing those two lines. We need to create in Dynamo those two lines. And then we need to create another line. And that line should be from, well, any point on your wall line, go up and go down like this. And then we're gonna make a test if this line, this whole line actually, like so, intersects with this line and with the upper line. It means those two walls need to be joined together. I don't know if I made my point clear, but that's what we're gonna do in Dynamo. So let me delete this. That's our whole end goal. And so, and let's go back to Dynamo. The first thing what we need to do is to make our wall lines. And we're doing that by using the node element and get location. Get location. This gives us back the location lines of the walls. So if we connect element to it, we can already see in the background, it made all our wall lines. And this were the green lines that I drew earlier in Revit. So now we need to make a second line that's going like this. And over here as well, and maybe over here. Doesn't really matter. But we need to make them. And we need to make them not randomly, because the wall line can be over here. Can be somewhere. Oh, let me just click on here. Can be over here somewhere on this side. So we need to make them from our, like so. We need to make them from our wall lines. So we have our geometry from a wall, and now we're gonna rotate our geometry for a new line. So what we need to do is first we need to get the direction of the geometry. So if you go into our node, we open it, and we see it gives back a line, start point, it has an end point, and somewhere in this list is a, yes, here, direction. The direction is a vector, and the direction for the first wall is minus 20 meters in the x direction, and it doesn't have a y direction and a z direction, and the length is 20 meters. So we need to obtain that parameter from our line. So we type in here get direction, or get direction line dot direction, direction, the direction of the curve. Yes. If we connect our geometry with our line, let's move it over here. We now can see in our output, it gives back our direction. And you can see for some lines, it has an x and a y direction. And this means it's not aligned with the x or with the y direction. So I'm assuming it's one of those, let me see, yes, the 7 meter should be this line. And for the example, its x is 6 meters. So it goes from here to here. This is 6 meters. And the y is 3.5, and that's from here to here. That's what those numbers are saying. And the z direction is 0 because it doesn't go up and down. It just the line is just on the x and the y direction. All right, that's the direction. And now we need to rotate our direction. So we type in here vector or direction dot rotate. And we have a node here, and it says rotate x and degrees. That's what we need. And the input is our vector and x as a vector as well, and degrees. First, what we can connect is our own direction to the bottom vector, and then we need to make an x. So we type in here vector, because we should put it in as a vector, so we need to create one. And by coordinates x, y, and z, yes. All right, this is our x, and we need to make an x in the z direction. So just double click and say, for example, 0.5 meter. It doesn't really matter what the number is, as long as it is not 0. And connect it to the z direction. And now we can connect it to the x. And what this does is, for this node, it will rotate on the x. And the x now is in the z direction. So it will rotate on the x of the z direction. It's a little bit hard to explain, but I can show you in a little bit what this does, because then we can play around with it. So the only input that we need is a degree, and let me double click. We say 90 degrees, and then we connect it. All right, this is our new direction, and as we can see, it just swaps the x and the y with each other. So the y is now minus 20 meters instead of the x. So here's the x. The X is here, 20 meters, and it's now the Y direction. That's because we rotated it 90 degrees. All right, let's move on. Oh, so the next thing that we need to do is to create a line. And now we need a line, so we type in line. And the node that we need is on the bottom here by start point direction length. And this allows us to create a line with a start point in a certain direction with a specified length. Well, we do know our direction. We just created it, direction. Our length, well, it's a number. So let's say, for example, our length is a meter. And we can connect it in. And now the only thing that we need to assign to this node is a start point. And the start point should be somewhere on our wall line. So we need our wall line, or our line, that's over here. This is our wall line. And we need to make a point on those line, on that line. So we are using for that curve dot, oh, let me type it right, curve dot point. And there should be a node somewhere here, points at equal chord lengths. Yes, this is it. So now we're going to connect those. We say our geometry is our curve, and the division, oh, as you can see in the background, it already did something. That's because the division is a default value of 10, but we are using 2. Let's connect it up. And let me see, I just selected something here. All right. All right, now we have our division we have set. Now we have our points. And let me connect the points to our start point and let me explain what happened here. You can see in the background, it already created a nice line. That's our detection line. Let me zoom in a bit. We created 2 points because if the wall starts over here, for example, and ends over here, like the cursor is right now, and it will, this line will detect it, and it will say, all right, this wall, and this wall needs to be joined with each other. But this wall, what I'm representing right now, is not on this side. It's just going from here to here, and that's it. And then it joins this wall as well, and maybe you don't want that. For example, another example actually, if I say 3, you can see this detection line also detects this wall of what's over here. And in my example, I don't want to join this wall with this wall. So that's why we're using 3 detection lines. And if this detection line detects this wall, this detection line should be doing it as well, and this one as well. And then if they are all 3 detecting the same object, then I want those 2 walls joining each other. So that is what this is doing. And now we need to create another line in another direction, because as you can see in the background, oh, like here, it goes one way. And what if there's a wall on the other side? So it goes only up in this case. And what if there's a wall here? It won't see it because the line is not there. So we need to create, oh, sorry. We need to create another line. And we can just copy and paste this node. All right. And the length should now be, let me copy and paste the code block, minus a meter. Minus a meter. And now we can see in the background, it made 2 lines on the same point. And this is our truly detecting point, or detecting line. The next thing that we need to do is to create a list of our lines. So list, hit the add button and connect our 2 outputs of the lines. So now we have 3 lines for each wall, and we have 3 other lines for the other side of the wall. So we have 6 lines in total for each wall. And all right, the next thing that we need to do is we're going to join those 2 lines up. So we have 1 line. So we have in total 3 lines of our wall, and we don't have 6. So we need to search for polycurve. Polycurve. And what we want to do is by joined curves. Yes, this is the node that we need. Makes polycurve by joining curves, flips curves as needed for connectivity. It will flip the start and the end point if it's needed. That's what it's saying. Alright, if we connect our list to our polycurve, you will see you get an error. And this error is curve joint produced more than one wire in polycurve. What this means is, let me show you. We have this line. Oh, let me click on the first. It's over here. This is the start point. And if we click to the second one, it's nowhere there. And if we zoom out, it's over there. And joined by curve cannot join this line with this line. It won't be possible because there's nothing between them. So we need to reorder our list. That's actually what it's saying. And we need to do that by our, and that's because we have in the top we have our three lines in one direction, and on the bottom we have our three lines in the other direction. So as we can see here, we have two lists, and we need this line in the same list as this line. So we need to transpose a whole list. So let's use transpose. Wow, transpose, really good. Transpose, and we need to connect our list. All right, and let's see the output. So now, the output is now we get 15 lists. As you can see, let me scroll down. 15 lists, or 16 actually, because 0 is a list as well. And now we have, this is our first point. Let me deselect this for the view. And this is my second point, but it's still the same. So we need now this point and this point in one list. And how we're going to do that is we need to transpose our list again, only now with a list map. And let's search for list map, dot map. And now we're going to say for every list, so we have 15 lists in total, or 16. For every list, you need to transpose this list. Oh, I can't select them, but we need to transpose 0, 1, 2, or this list and this list. That's what we're going to transpose. So our list map, our function is transpose, and our list is the output of our list transpose. Let's connect it. And as we can see right now, we have a list with a first line. Oh, let me deselect this. It's easier to see. And the second line is also over there. So now we can connect it to our polycurve. And if we connect it, it will give back 32 or 48 curves. And if I select one, let me deselect this. Select the first one. It's this curve over here. So that's all good right now. And our polycurve is our detection line. So the next thing that we need to do is we're going to make our class detection. And we're doing this by using geometry. So geometry, and that does intersect right here. Determine if another geometry object intersects with this one. Yes. So what we need to do is, let me use a watch node. Watch. We have our polycurves. And we have our, oh, sorry, I selected something. Come over here. We have our wall lines. And what we want to do is, now we want to use the geometry that does intersect. If the wall line intersects with one of the curves, it needs to give us a true. So now we can make our filter. We can say, all right, this is our other geometry, because I want for every line, for every wall line, I want to know which polycurve is there. So now we need a list map again, list.map. And our list is, a list of wall lines, because we want to see for every single line. And our function is our does it intersect. And if we connect those up, we can see here in the output. All right. Let me just tell you what this is all saying right now. Let me collapse a few. We have 15 lists. SUO. Let me show you. Yes, here. 15. We have 16 lists. It returns 16 lists. And list 1 represents wall 0. Or represent wall 0. And wall 0 intersects with wall 0 itself. And let me see, intersects it with something else. It intersects with, yep. And it intersects with wall 14. So now we know wall 0 and wall 14 are, for example, this is wall 0 and this should be wall 14 then. That's what we know right now. And now the first thing what we need to do is to make sure the wall is over there, and we're doing that by using our lines. So we can see, for the example, the output is true, true, true. It means that all 3 detection lines are in the wall. If something is false in the same list, it means it's only in 2 intersection points or in 2 detection lines. And that's not what we need. We want the wall in all detections. So we say all true. All true. And we need 2 list maps for this, because we want to go for every list. So list 1 or list map 1 is for this. And then we want for this one as well. So we need another list map, and then it checks if those 3 are true. So we say list map, and we need them twice. So we have here a list map, and our list is our boolean. And the function of a list map is another list map, and the function of this list map is our what we want. So let's connect it all up, and as you can see, it gives us back, all right, list 0 as wall 0 and wall 14 inside them. List 2 has wall 1 and wall 13 inside it. All right, from here we can make a big filter. So we say filter by bool mask. So this is used to be a big filter, and we need another list map. And we're using a lot of them. And let me think. Our list is our boolean. It's weird. We need to check for every true, for every item inside this whole list, if something can go on or has to filter out. So that's why our list is our bool actually. And our function is of course our list filter by bool. So the list map knows what to do. And the items that needs to be filtered are our elements. So let me just move this over here and click on elements. And this is our other list. And now the output are 24 items. And we can see this is wall 0 and this is wall representing wall 14. And those 2 are now in the same list. And this is our order for our custom node. We need element 1 and element 2, element 3 and element 4, like I showed you before in the code block. The only thing that we need to do right now is to get only the unique items, and we need to make another filter. Because the unique items, this wall has a detection line, and it will detect this wall, the outside wall. But the outside wall also has a detection line, and it will check for the inside wall. So it means we have twice the same data. So if we see here, it ends with 38 and with 70. If you scroll down, 38 and 70. They're twice in the same list. So we need unique items. Create a new list containing all unique items in the given list. That's what we need. So let me move it over here and connect it. And now you can see it gives us back 16 items, and we have 16 walls inside our model. So that's all good. We have no duplicated items anymore. And what we need to do now is to get rid of the single walls. As you can see, we have a lot of single walls here, and we need to get rid of them, because if you want to join a wall, you cannot join the wall with itself. So we need to count the items. Count. And we don't need to count our lists, because we already know there are 12 lists. We need to count the items inside the list. So we need a list map again. List.map. And our function is count. And our list is our item list. And now you can see it will return 2, 2, 2, 2, and all single ones. So now we're going to test them. And we're going to test them on greater. We're going to test them on greater. So what we're going to do is, if this number is greater than 1, so let me type in here 1, it needs to be true. If it's 1 or less, it needs to be false. So let's connect it. And as you can see, the computer is a little bit slow. It gives us back 4 times true, and the rest of the items are false because it's 1 and it's not greater than 1. So now we can use a filter by bool, and we can say this is our mask. This is what true or false, and our list is the output of the list unique items. So connect it. And now if you use a watch node, watch node, connect it in here, and you can see it returned 8 walls. And in our model we have 8 walls that we want to join. We have wall 1, let me just click here. We have wall 1 and wall 2, wall 1 and wall 2, wall 3, wall 4, 5 and 6, and over here 7 and 8. So this is our end list, and now we can connect it to our custom node. And our custom node was element.join, like this. And now we can connect it, like so. And if we go to our Revit model, we can see it joined those 2 walls with each other, and it makes a hole in a wall. And if we go to our 3D, like so, now you can see we have our windows. We can see them, we can see our door, because all of the walls are joined that needs to be joined. So, and that's it for this episode. I hope you enjoyed this video, and it's also the end of the series. So I hope you enjoyed the whole series as well. And I thank you all for watching. Make sure to visit our website. Bye bye.